Yes. It seems like it's a little bit back and forth. It did go off once this morning though, so I didn't know. Alright, first thing I need to share with you guys is Google Classroom. Yesterday I posted an announcement about mock exam. So we do offer a mock exam. It is on a Saturday in a couple weeks. I don't remember the exact date, but it's on Google Classroom. There is a Google form that you should fill out, especially if you plan on coming, because we do get some food, like some donuts and stuff, if you're going to be there, and we have to make copies of it. So you're certainly encouraged to do it. It is optional being on a Saturday. There's not a grade attached to it or anything like that, but it is kind of nice to take it, kind of see where you stand, realize that maybe you need to buckle down more than you thought, or maybe you're in better shape than you thought, but just giving yourself some idea of where you're at. Yeah. It'll be till about noon, 12:30. Yeah.
When would the scores be released?
So the multiple choice, you would know almost right away, because we have you put it in a Google form and it just spits the answer right back out at you. The FRQs, you have to look at those and grade those. So that would be, you could do that like the next advisory if you wanted to. Also, one benefit of doing the mock exam is that we will go over some of the questions in class. So if you took the mock exam, you already know if you got that question right or not, whereas people who don't take it might be seeing it for the first time. So if you did the mock exam, and we were doing a few multiple choice questions that you got right, you could go and check your answers to the FRQ to see how you did. So FRQ is plural. The other thing about that is if you can't come, again, I understand it's a Saturday. I wouldn't do it if I didn't have to, but it is the one that we will use, I believe, unless we make a change this year, and I don't know why we would, is one that I can open up in Google Classroom for you. So in theory, you could do it on your own time, some other time, but if you don't really time yourself and make it like a real testing environment, then you may, if you let yourself have breaks in between them, then that could mislead your score and stuff. So, but if you absolutely can't come, there will still be that as kind of a backup. So anyway, I wanted to give you a heads up about that. So if you can come, if you think you're likely to come, but you're not 100% sure, just say that you are coming. That way we will have a book for you and maybe some food for you if you do show up. And if you don't show up, it's not going to really hurt anything. But I need you to sign up for that. Any other questions there? Okay. So I've got a couple handouts for you guys. Got the number that, I did it down there. Okay, so first off, number 107 is the one-sided piece of paper that says volumes from rotations around lines other than the X or Y axis. So this is actually what we were doing before break, but we always rotated things around the X axis or the Y axis. Now we're going to look at some lines other than that. Secondly, we're going to actually get in some real practice on those type of volume questions where you spin it around a horizontal line or a vertical line. So again, we practiced this just a touch before spring break. One day I showed you the DISC method. You did like 4 Khan Academy questions times however many tries it took you. And another day we did the washer method times however many Khan Academy tries you had to redo. So that circuit is those same type of questions so that you actually get some significant practice and not just a couple. So that will be our focus today. Quite a few people have asked about the last test. The last test is not this week. My guess would probably be near the end of next week. Usually with the last unit test, we're usually not too much in a hurry to give it because we will start transitioning into AP review. And so, if we don't test right away, it gives you more time to study if you need to study more. And if you don't need to study more, it doesn't really hurt anything. So, but you guys have seen all of the stuff. There's just a couple little things, like we need to review L'Hopital's rule. I showed that to you first semester, and we will put it in this unit, so I'll make sure that you see that again. Working questions like we are today, which are just an extension of what we did before. It's slightly different, but mostly the same thing. We did volume from known cross sections before the break. That would be part of your last test. And area between two curves. We did quite a bit of practice on, so that makes up the last unit. And there'll be a handful of small things like what I have written on the board. Like I never made you memorize the derivative of inverse tangent, but that's something you need to know for the AP exam. So there'll be a few small things sprinkled in, but for the most part, we are into AP review mode. One thing to consider though is I counted up the number of class days that we had until May 8th, which is your AP exam, and I don't remember what it was. Something like 15 maybe, 12 class periods, because I only see you guys 5 times every 2 weeks. But what you have to understand is the week before ours, I think there's other AP exams, so you may miss a class or two those days. If we test, when we test this last unit, that's probably 1 day gone. I think there's ACT Aspire coming up. That might be like a half-day thing. I don't know what the schedule is. I've just heard some rumors. So that might be a day gone. So all of our AP review time, it's actually much closer than you realize. So we got to take full advantage of that kind of stuff. So with that in mind, even though this isn't exactly AP review, this is, I still think you should maybe think of it as AP review, because if you learn this stuff well now, of course that means you've got to study less for this last test, but also it means that when you're studying for the AP exam, hopefully this is something you feel solid on and you can worry about other stuff and not this stuff. So it can pay off in that way. So let's go ahead and talk about 107 and what's going to be different. But before we do that, we're going to review what we did before spring break, since you might be a little rusty since it's been a couple weeks. So we're going to review the DIS method, washer method, and then the last 2 questions I'm going to show you the little tiny bit that can make it a little bit harder if you're not careful. So it's not actually harder, but it would be harder if I didn't point it out to you. Okay, so we looked at some questions where we had an area that was bounded by a bunch of lines. So let's go ahead and do a quick little sketch. Y equals 3, x equals 5, y-axis, x-axis. So all of those lines are going to trap in some area, and then we rotated that stuff. So questions 1 and 2 are the same thing, except one of them is rotating around the x-axis and one is rotating around the y-axis. So when we rotated around the x-axis, we said it would be dx, and if we were rotating around the y-axis, it would be dy. The big difference is, if it's dx, you need to be looking at x values, like 0 to 5. And if it's dy, you need to be looking at y values, like 0 to 3. But when we spin this 2-dimensional area, it creates a 3-dimensional shape. And we found the volume of that 3-dimensional shape by adding up an infinite number of, what kind of shape did we use?
You're talking about the disc? The
Yeah.
discs here?
Yeah, circles. So this method, basically circles. So that's why it was always add up an infinite number of pi r squared That's why it was always pi r squared, because we're really just doing an infinite number of circles. And on the harder questions, sometimes it helps, like if we're rotating it around the x-axis, we might draw in a couple of those cross sections, some of those circles would look like, and then we can visualize that the radius is 3. But if we were rotating it around the y-axis, looks like the radius would be 5. And so that's basically the DIS method. There's no gap in area between our enclosed area and what we're spinning it around. So there's not going to be a gap in volume. So that's what makes these two DIS method. And then, of course, this is pretty easy to integrate. 9 integrated would be 9x. Plug in 5, plug in 0, subtract 45 pi. Might as well go ahead and finish. Over here, this would be 25, so integrating 25 would be 25x. Evaluating 3 to 0 would end up with 75 pi as an answer. So those two make up the disk method. Pi r squared, because it's an infinite number of circles. Paying close attention to whether it's dx, dy, and 0 to 5 to 0 to 3. Okay. You guys remember all that? We okay to move on? Okay. Then the washer method was like 3 and 4, so we need to make a separate graph for each of these. 1, 2, 3. And I tried to pick out some pretty easy ones to start off with here, just so we could really focus on the process and not the arithmetic. But question 3, after you graph it, this would be R, the enclosed region. So if you spin this around the x-axis, it's going to be dx. Because it's dx, I should be looking at x values, 0 to 5. Now, do you guys see why this is going to be washer method instead of disk method? Since we're rotating it around the x-axis and there's this space right here, there's a gap in area next to the thing we're going to rotate it to. When we spin it, that's going to create a gap in volume. So instead of just being pi r squared, what did we have to do different? You remember the structure of that?
Yeah, you subtract that little part.
Subtract what?
The little circle, or the whole, the little part.
Okay, so big radius squared minus small radius squared. And you could do this as 2 separate integrals. Pi r squared, capital R, would be the area of the big shape. And then come back and take away how much volume is not in there. That's here in the middle, which is the small r. Or you can just cram it together into one big integral like this. So if we rotate it this way, this point is going to swing around. It looks like our big radius is always 3. And then our small radius would be these, which is always going to be 1. And finding the big radius length, finding the small radius length, it's not always going to be a number. Sometimes it's part of the equation, but that's the part you have to slow down on. That's the part that takes some thought. So to just go ahead and finish this would be 8. Integrate 8 becomes 8x from 0 to 5 times pi gives you 45 pi, or 40 pi. So washer method, really just one extra piece here, but slow down on finding the big R and the small r. But otherwise, washer method can always be set up this way: pi, big R squared minus small r squared. Okay, and then let's look at one example of rotating around the y-axis. And then the bottom 2 questions will be what's new. Again, this is just me trying to remind you what we did before break, because we're going to go past that. Now, question 4, technically, if this was rotated around the x-axis, this would be disk method, because the area is hugged up all the way around the x-axis, so there would be no gap in area, so no gap in volume. But because it says rotate around the y-axis, this gap in area next to the y-axis is going to create a gap in volume, so this is why this one is a washer question. So pi big R squared minus little r squared dy, because we're rotating around the y-axis, 0 to 3 because that's the smallest and biggest y values. And especially if you have a picture, or if it's very easy to make a picture, you should sketch in a couple of these cross sections. This point, swing around the y-axis. This helps me see that the big radius is 5. Y'all see that? And the small radius is going to be this inside. That's going to be non-existent, which is why we're subtracting it away. But it looks like it always has a radius of 2. So, and again, I made these really easy, but just to review the concepts. 25 minus 4 would be 21. Integrate 21 would be 21x, or in our case, 21y. Plug in 3, plug in 0, you get 63 pi. Now it's important that you remember these, that you understand what's going on in these questions, or 5 and 6 are not going to work out for you. So, is there anything specific about 1 through 4 y'all want clarification on? Okay. Then let's go ahead and just dive into question 5, and you'll see what is slightly different here. So, at first, nothing seems different. R is bounded by y equals 1, x equals 6, the y-axis and the x-axis. So here is region R. Now, if I was rotating that around the x-axis, would that be this method or washer method?
This.
Good. And if I rotated around the y-axis, would it be disk or washer?
This.
They would both be disk. But what is different about this, and you're going to see a couple of these question types, I just didn't throw this at you before the break. I'm not rotating this around the x-axis or the y-axis. I'm going to rotate it around y equals -1. This is the line I'm going to spin that area around. Well, up in questions 1 through 4, if we rotated around the x-axis, we did dx and used x values for the limits of integration. If it was spun around the y-axis, we did dy and used y values for the limits of integration. Do you think this is going to be dx or dy? Okay, what makes you think that? You're correct, but
It's parallel. X-axis.
Because you're spinning around.
You're going that direction.
this line and the x-axis are both what kind of lines?
Parallel.
Well, they're parallel to each other. Horizontal, there you go. So it's really not about, if you spin it around the x-axis, is not why it's dx. If you spin it around a horizontal line, it's dx. If you spin it around a vertical line, like we're going to do down here, it's going to be dy. So, I didn't really lie to you, I just didn't give you the full truth. Okay, also, so since this is dx, because we're spinning it around a horizontal line, we should be looking at x values, so 0 to 6. Now, can you see why this one's going to be washer now? Because it's got this gap here. So, I know it's going to be pi big R squared minus little r squared. Now, I will also add that finding the radius lengths, even though I think it's the hardest part, it is just a touch harder on these because you're not just measuring from here to the x-axis or here to the y-axis. If I spin this around this line, it's going to look like this. So that would be the big circle because I'm using the outside point. What is that radius length?
2.
Good. From here to here is 2. It's 1 to get to the x-axis and 1 to get up here. So the big radius is 2, and then the small radius would be this, the part that's not there that we're taking away, and it has a radius of 1. So it's a tiny bit harder to find the radius lengths because the lines are not as distinct, but you really are approaching the same thing. All I'm really telling you new is that rotating around a horizontal line, not just the x-axis, is dx. But then if we integrate this, you get, I don't know, 3x, and don't forget the pi. Forgetting pi is probably one of the more common FRQ mistakes, but it's a bunch of circles, so you need the pi r squared, not area of a circle without a pi. Okay, let's look at one more where we're rotating it around a different line that's not the x-axis or y-axis. And so we've got y equals 2, x equals 5, x-axis, y-axis. Again, I'm trying to keep that part as simple as possible so you can focus on what's new here. So this would be this method if I was rotating around the x-axis or the y-axis, but this time I'm asking you to rotate it around y equals 7, or x equals 7, which is all the way over here. So now there's this gap in area next to what we're rotating it around, so now it's washer method. So pi big R squared, little r squared. Since I'm rotating it around a vertical line as wide as dy, and I'm using y values, 0 to 2. And just be extra careful with your radius lengths. If I take this outside point and rotate it around this line, you're more likely to see that this radius length is 7. And the small radius length would be the inside point, which would be 2. So that stuff makes 45. 45 integrates into 45x. And so 90 pi. So all I'm telling you basically is be a little more careful with finding the radius lengths. If you rotate around the x-axis or any horizontal line, it's dx. If you rotate around the y-axis or any vertical line, it's dy. Otherwise, it's the same thing we did before break. I just didn't ask you to do much practice. I only asked you to do a couple Khan Academy things. So next up would be 108, which is the circuit. So the circuit starts off pretty easy. Some this method. This method, rotating around the x-axis for a while. Eventually some washer methods, eventually rotating around vertical, horizontal lines. But this is what you should aim to try to finish in class. So go ahead and start on that, and then we'll talk about what I will be asking for as far as homework grades and stuff next class. On this one, this circuit does a better job where I haven't let you use the calculator to integrate everything. That's not true on this one. I do want you to do some of the integration by hand on this one. So if you look at the questions, if it doesn't put 2 stars by it, that means you should integrate it by hand because it's like insanely easy to integrate, so it's good practice for y'all. But like if you look on the bottom right question on the front page, the one that says answer 192 pi, do you see those 2 asterisks before the question? Mm-hmm. That means it's pretty tough to integrate and just use a calculator. So use a calculator to do some of the integration, but the basic ones you should do and show your work for. So let me give you a head start, and I'll come around and make sure things are still going well here in a few minutes. Again, this will probably be the last day we look at these question types, so you need to feel as solid on these as you can. you're having any issues with the first couple, just call me over as I come around. And I'll help you get on track.
Six pi.
But you just have to put the equation we're talking about, not the pie chart, so just get
So
to that.
when we're,
I think I
we're
can.
doing these quadrants and cross sections,
That
we're
was-
doing
yeah,
that number.
Wait, what did we do? Did y'all put the area?
Circle
I put
the
three
pi,
there.
R squared.
Oh.
Cause you put,
Oh, cause you put the
yeah,
area.
no,
on
you
the-
put the,
Yeah, you guys
the
have to
line.
boil that out.
Last
I
time was
knew
not a
that.
good week for me. But we got a week before, it's been great.
So did we get the last one wrong too?
Yeah, positive.
I don't.
It's an equation, different equation.
Oh, okay, I see.
Like when you square something like this, you don't get into the square root each thing, you actually have to boil it out. You lost and then. Did you try back here?
No, are we supposed to like, we put this
Yeah,
on
it's
top, or do you wanna like try to do it?
Yeah, you should do that one. That's probably the hardest one to do by hand, but you can do it. 2 stars, use a calculator. No stars, use it by hand.
That's like a minus two.
So you need to FOIL it out, make sure you get 3 terms, not 2 terms. And then it should come out to 6 pi, so it all works out at the end.
Oh wait, actually, I think X squared is 2, right? I'm gonna try it. Okay. What are the bounds? 0, 2, 0, 2, minus 2 squared. Oh wait, yeah, you're squared. What's next? What did I do? Yeah. Wait, maybe I didn't. Yeah, I don't think.
Number 4.
Yeah, I think we tried top on bottom, but I tried this one. That's not
I
right.
disagree with your marker. Your circles look good, but this length is always y. See how the radius,
Oh, so just X squared?
yeah, all that's just x squared. Squared. and it's radius.
Overthinking it.
Or would you
Wait,
say?
what?
Or would it?
Yeah, you just.
Yeah, we choose
You
a
just-
term.
Radius of each square is
So
x
for
squared.
F, like this would be positive O, this would be negative.
But that changes with that
O,
function.
this would be
Yeah.
negative. Would be 2
So
negative.
you don't need to do anything with 2 and they're all to square.
Straight.
Okay, so X squared, that's X squared.
Are these? Oh, yeah, we have the same. I put 18 over 2, and you put 9. I was like, oh wait. Thank you.
Did Chris have a friend in college? She didn't. In college? She didn't make friends.
I know.
How does she?
I'm sorry.
I just feel like she just wants to advice for this like Oh, really? So, but at least
All right, I've got 22 after, so to start back, maybe if there's a question or two that you guys got to before break, before your lunch break, that you were having trouble with, I could go ahead and do that on the board in case other people have issues. So, question 1, everyone finished that one? Got 96 pi. Okay, number 2. Everybody get 6 pi. We don't need to see number 2 worked out. Okay, how about number 3? I got an answer of 80 pi. Correct? Okay. Number 4, I got 32 pi fifths. And maybe number 5, I got 128 pi fifths. I know most people, you may not have gotten that far, that's fine. I'm just, if you had a problem with any of the first ones, you guys know that these slowly ramp up difficulty, so if there's something holding you back in the first few, you might as well ask. So, any of those first 5 I could help with? Okay, I will check back in about 10-15 minutes.
This is not my mistake, but why wouldn't it use that same equation as 4? Even though it's no, because it's not the same. Right, but the radius, I mean the bound is 0, 2, 3. And then we just
0, 2.
It's right in the point.
No, this one you do just
How do you know that?
because on this one it's already up against the axis. So we come up with our space. On this one,
Oh, you
it's
just
calculating
subtract
that white space.
Okay.
So the x squared it'd be 4. The 4 is the big white space, right? Actually,
Oh,
you're
so
right.
before
No, you're
minus
right.
x squared. No, I think that makes
No,
sense.
yeah, 4, because it takes the whole
So
square.
4 minus x squared.
4 squared.
Or
Yeah,
4
I'll
squared
go-
minus x squared squared.
Yeah.
Okay.
Yeah. 4 minus x squared squared.
Okay, that's 32 minus 32. 160 minus 32. 128 over 50. Oh wait, isn't that what you said? Yeah. I'll just 175. Oh good, we get
I don't know
that.
how to do that.
Come on. It's too hard. I think it'd be 4x minus x squared times x squared. So top is 4x minus x squared minus x squared.
Yeah, and you take it in. So you only need that if it's 11. What if it's 11? Maybe doesn't get under. Oh, it's taking that. Let me try it.
Okay. 32 pi. It's an answer. I think that is.
Oh, another one.
Yeah. Oh wait, it is 6 because all of this. So it's 192. I have less. I don't think we need all of these done today. Well, actually, we can do it. We just have 11 more. We've done 7.
You said 1 on the 2 column.
Yeah. It's on the front page.
Okay, just a couple more minutes and then I would be willing to work a question or two on the board. So if you have something that's holding you back, just be ready to ask, please.
Is this an
rotation in this. And it's rotated all the way.
Yeah, but
About
this is-
this way. That's what
Oh. Okay, so then you would just do 4 squared minus x squared. You know? Because it's kind of like. Oh wait, now I think I squares. Would that work? Because that's what we did here, so. Wait, that's confusing.
Yeah, I'm a little.
I don't understand.
All right, it's been 10 minutes since I asked for questions on the board. So, I don't know, any of the first 5, 6, 7 questions?
8.
Number 8. Make sure my 8 is the same as your 8. Is this your number 8? Let's see. Okay, so x squared. Let's see, x equals 2. And the line y equals 4. Oh, and the x-axis. Okay, so first off, is this the trapped area that you had?
Yeah.
Okay, so this one we're supposed to be rotating it around y equals 4. So this is a horizontal line, which means it would be dx. So looks like it should be 0 to 2. And if I rotate it this way, all of this gap in area is going to end up creating a gap in volume. So this would be a washer question. Not that you ever need to describe it as disk or washer, but it kind of helps you know what your setup needs to be. So if I take this outside point and rotate it around the line that they say, and maybe this point, rotate it around the line they say, it looks like the radius is always this, 4. Big R is 4. And then small r would be the inside part that doesn't exist. Now that's a lot harder to find, that radius.
Yeah.
So we need to come up with almost like a small equation that always gives us this radius length. So when x is 2, we want the radius to be 0. When x is 0, we want the radius to be 4. And then we want it to change with this curve. Yeah, very good. 4 minus x squared. So when x is 0, you want it to be 4. So that works for that. When x is 2, you want this to be 0. That works for that. So it's trying to go down to 4, but subtract wherever the x squared is. And that's a calculator integration one, so you can just throw all that in the calculator. But make sure you do that so that you know how to change your decimal to a fraction. But you should come up with that. That's one of the harder radiuses to find. So. Okay, one more. Questions 1 through 7. Okay, let me give you a few more minutes then.
It's like this. It is?
It's rationalized though,
How would you get 7 of that? The radius. The 7. But only the radius. No, I did. I just drew the circles.
because I think the circles change.
This would be the middle of the washer.
Yeah.
Also this one.
You know, 'cause you're doing it around to that line. It was only up there because we have.
But whenever you rotate this,
I know.
you rotate like all of it. Yeah. So you rotate from the top to the bottom. So rotate all of that. And then it has like a it looks like that, you know, whenever you rotate it.
I know.
But then you have
No, because you're just going to say the shaded part. So it's going to leave out. It's already going to leave out that there.
oh.
Yeah, but a different line.
Are you? I see, I don't know. Oh, so it's gonna look like that.
For the small radius,
Yeah,
Well,
it's just kind of not.
that's the only thing that
Oh,
works.
so then you subtract 3
What else do you
squared.
think would give you that small radius?
Wait.
Yeah.
Well,
Yeah, you
would
subtract
mean-
3 squared, but I don't know what goes first.
if you said the small
But it
radius is
doesn't-
x squared, at x equals 1, you'd be saying the radius is 1, but the radius is actually 3.
Yeah.
Right?
Because it's trying to go down to
Oh.
4,
It's
but then it has to
X squared
subtract wherever the x squared is.
plus.
It's that much Usually the best
This
thing
is
to do on
X.
those
Yeah, that's not X squared.
is try something, plug in a
That's
couple x values
4
that you
minus
know,
X
like I know this is supposed to be 4, but
Because
x
remember
equals
on this
0.
one?
I know this is supposed to be 0 and x equals 2,
Well,
and yours
wait,
doesn't
this
match
is
up with that.
this right here is 4. This is 4 minus X
Then it
squared.
can't be correct.
Oh, it is?
You gotta try something else.
Yeah, because this is this part. This is X squared.
Oh.
So in
But
order
that
for
makes
this.
design similar.
No.
You can get for-
Okay, okay. So you do
No.
4 minus x squared minus 3 squared? With extra squared?
4 minus X squared
almost
squared.
It's like right here. Like this length,
Minus
that's supposed to
3
be,
squared squared
yeah,
dx. Okay. Oh,
this
Maybe.
length is supposed to be 3
First.
first, and x equals 0, and that works for this.
0 to 2.
So
What is
this
that right here? That's the big radius on the far right. This would be 3 plus that.
Yeah, that's right. Oh, well, yeah.
So 7, I guess.
Negative 14, 15.
So then x equals 2.
Negative 0.9.
Right, it needs to be plus.
Yeah, but
This
it's a
distance
fraction that's.
plus
negative
however
14,
much more you
15.
need to get to the x squared.
I don't think that's an answer.
But now it's a,
Yeah, that's not an answer.
and that one's a calculator. So you can write that one as a calculator. I mean, you can do it by hand.
I
but
honestly think you
it's
have
gonna
to
be
add
long.
3 to this.
Add 3?
So it's 7 minus X squared squared minus 3 squared. Let me just try that really quick.
Okay.
That's what I was thinking. I was thinking it was a 7. But you almost said it was
736 over 15.
I
That's
have
high there.
everything.
Yeah, that's not.
Okay, so part of it is that your area is supposed to be trapped
I
in
think it's just
the
X
y-axis
squared.
too.
X
So
squared squared
really
minus
only
three
half of
squared.
that.
Oh, so it's only right here.
Or that side, either one, it doesn't specify. But it's the same amount of
What's your
area, so
problem?
it doesn't matter.
Negative 11.6.
Okay, so it's when I go over that was some fraction.
Yeah, that's how you start.
That's the bit. Was that a fraction?
256 over 15. Negative 58 fifths. I don't think any of these are negative though. You can't have a negative.
Oh, wait,
You think you have a negative area.
Oh my god.
Still, well, I don't know, the way
What
you
are we
got it written down,
doing?
may not have
No.
been calculated.
We've gotten a negative every time.
I bet you this is gonna be the answer. 112. That's the answer.
Yeah, it is. Pi.
That's my
Pi,
guess.
pi. But, the other thing, so one thing I had
The big
different than you was the
radius
bound. I
is
just said
from
0
the
to 2,
negative
you had said
three
negative
up
2
to that 4, but it also
It also looked like
changes.
you had your big radius and
So
small
it has to
radius
be the
switched.
question. Oh yeah, I changed it.
Oh,
I forgot
okay.
to change it. Wait,
Maybe it's
Were you in trouble earlier?
3 squared.
no, that was the bilateral thing.
What was it?
I
Was
passed
your
it by
equation?
I just did it. Okay,
You
so-
passed?
Does it
Nice.
count? If you didn't fill out the form right?
Yeah, that's what I was squared.
Okay, we have a question number 9.
Okay.
Yes.
So this is a picture here.
Okay, all that looks good.
But the picture or the equation?
The
Everything in the equation's okay so far, right?
What? Okay.
What do you mean, 0 to 2,
Right.
dx because it's a horizontal line.
Uh-huh. We're just confused on
It's
this
washer.
part, this first part, yeah, the
Right.
washer.
So pick one radius line to look at and draw it in there.
It's from here all the way, or from here to the -3, so it's 7.
So what is this distance always gonna be no matter which radius you pick?
3.
Okay. And this distance is always
No,
gonna be
4. No, it's gonna be the bigger, right? Isn't it gonna change because it's along that line?
okay.
I can't figure it
But this part's always 3.
Yeah.
Yeah.
Plus however much to get to this. Well, what is that?
7. Oh, x squared.
Yeah.
So it's 3 plus wherever x squared is.
Wouldn't it be,
Minus 3.
wait, so 4 minus x squared
Let me try to draw.
3 plus x.
minus 3 plus x?
No. 3 plus x squared minus 3 squared.
Huh?
I think.
Wait, 4 minus x squared gives you that. It gives you this.
What about your x squared? Because you take this is 3 plus this. which
That's
is
not x squared. That's 4 minus x squared. That's 3 plus 4 minus x squared. That's why it should be 7 minus x squared.
So it's not
Look,
that.
maybe we just got the second part wrong.
Yeah, read this picture though.
Yeah, me too. Actually, no.
Okay, so big radius is gonna come from outside part. Small radius is gonna come from inside part. So, like, if we're rotating it here,
Yeah, that one changes.
yeah, it changes, but it's always this distance, which is 3, plus however much you gotta get up to x squared.
But I thought in the last one that we did, that little area below the x squared graph was 4 minus x squared.
What was the last question? I don't know.
It was number 8.
That was the one we were just talking about.
Oh, it
That
was
one's up there.
the answer.
That's on the board right there.
Yeah.
Okay.
What's under the graph is 4 minus x squared.
Correct.
Right, so why should it be, why isn't it 3 plus 4 minus x squared?
Well, this one you were rotating it around
You
where
were
y
on
equals
the
4, which is
above.
way up there.
Yeah.
This one you're rotating it around x equals
Negative.
-3, which is way down here.
Times it by 2.
Yeah, but just to take the part underneath the, like underneath the x squared graph, isn't it 4 minus x squared?
What should the radius be when x is 0? Well,
I mean
it's
3.
Okay, so if you plug 0 into your equation, does it give you 3? Into your small radius?
What's the following one?
What do you think the small radius was? After write
It was.
On that one,
We're trying to fix it.
Oh, 7 on this one?
But
Okay,
we'll
7 plus
look
x
like
squared.
going half of the answer.
Okay, so when x is 0, you think the radius is
So
7.
we're just timing by 2.
When x is 0, the radius is definitely not 7.
Oh, yeah.
Hang on. 2.
When x is 2, the radius is supposed to be 2 plus 4 is 6.
Or 3 plus 4.
And 3 plus 4. Yeah.
Okay, so the
Well, I
7
didn't make out-
squared.
That doesn't help you get what the radius is supposed to be, but it helps you see that that doesn't work.
Yeah.
To me, it's this length is always 3. This length changes, but it's always the x squared. So 3 plus x squared, 3 plus x squared, 3 plus x squared, no matter what x is.
Oh, okay. So it'd be 7 squared minus 3 plus x squared? No,
There's 7.
It's 3 plus x squared minus, squared minus 3 squared.
112.
3
Oh,
plus
you're talking about
x
the other part of it
squared
too.
squared minus 3 squared.
We have
What'd you get?
112 over 5.
Stop, I guessed it.
And you did guess it right.
Okay, so I got time for one more check-in here. If you guys like to see 1 or 2 more questions on the board. Any of the first 10 that you've tried that you're having issues with? First 12? First 14? I know some people are further along than others. Alright, well, you got about 7 minutes of class, so try to finish up a question or two. And I did make a slight change here. So to make sure that you guys know what the expectations are, I will be asking for 2 things on Thursday or sooner. They're both in Google Classroom already, so you're welcome to turn them in early. One is this circuit. So I have all of these worked out on the website minus number 15 and 16, I think. I don't know why those 2 are missing, or 14 and 15. I guess people just have had less issues with those. You're also welcome to come in advisory tomorrow if you need help with it, but you either need to turn it in Google Classroom or be ready to hand it in physically on class Thursday. And the other assignment I'm going to take up is number 102, where we did volumes of solids from known cross sections. So we spent 1 full class period on that before spring break. And then 1 day before spring break, we also did those 1 Khan Academy assignment, and then the rest of class was to finish that up. So it is also opened up in Google Classroom. So as always, I encourage you to turn in both of those early. But your last chance to turn it in without late credit would be at the start of class on Thursday. I did have you pick up 109 also. You do not have to do it for homework yet. It is 3 practice FRQs. Very good practice for your last test. That's what I would anticipate one of your FRQs on your last test to look like. Very common for FRQ on the actual AP exam to have something about area. Whether area between 2 curves, a part of it being volume from known cross sections, like we did before spring break, and you're going to turn in before Thursday, and part of it being volume, whether disc or washer method, from rotating like you guys practiced today. So those 3 practice FRQs. Again, you don't have to do those before Thursday, but I will ask you to do them. So if you have time to get a jump start on them, you're welcome to.
Is Cassie working?